Hey guys, hope you are doing well today. I'm not sure if you're watching the videos on schedule, early or behind, but this is supposed to be Wednesday's video, April 24th. So if you've not printed your handouts, your notes, please pause the video and print those at this time. You'll need those for the class. And secondly, Chase and Matthew, you guys owe me a test and a quiz on Monday. Remember, if you have a couple questions on Monday, I suppose that's fine. But A, I cannot promise you we'll have time to answer those. And B, if you don't turn those in before you leave, you will lose points on your test and or quiz. So please feel free to email me, call me, whatever you need to do to ask questions this week on your test and your quiz. Okay? All right, moving on. Let's grab your notes, please. And let me grab my pen here real quick. If you'll look at the top of page 1 in your notes, we start off with 2 review problems reviewing yesterday's math, okay? So here we go. You should see this problem right here. Let me go ahead and do this and slide it over here. You should see this problem in your notes. Base 2 of x equals 28. And then you should see this problem here. Natural log of 2x plus 7 equals natural log of x minus 4. Now, each one of these is worth a half a bonus point in your account. So you have 2 choices. A, pause the video, work both of these out, and then check them. Or B, don't take the bonus points, just watch me work these out, review that way, and then just don't take any bonus points, okay? But I'm going to go ahead now at this time and start solving these. So if you're going to earn the bonus points, please pause the video and turn it back on when you're finished. Okay, here we go. Let's take a look at this first problem over here. We'll draw a dividing line right here. The equation to the left is a logarithmic equation, and it's the type of equation that has it has logs all on one side of the equation. There's none on the other side. So the steps I gave you for this type of logarithmic equation were something like this. Step 1, simplify one side all the way down to 1 logarithm. Well, we've almost done that, but we got a 3 right here we want to get rid of. So I'm going to very quickly divide both sides by 3. So now I'm left with log base 2 of x equals 28 over 3. Now, if you put 9.3, I'm okay with that. I'm not going to lose a whole lot of sleep over that. Either way is fine. I'm going to go ahead and leave mine 28 over 3 for right now. Okay? All right, let's continue on. Step 2 then said to write the equation exponentially. So if you wrote this exponentially, it would be x equals 2 to the 28th third power. Now, some of you might have 2 to the 9.3 power, and that's okay. I don't care. That's fine. Well, if you type this into your calculator, which I have not done yet, so let me grab my handy dandy TI grapher and let me type this in. 2 to the 28th third power, I'm getting this right here for my answer. X equals 645.08. Now, you might be off a hair, and that's okay, but that's pretty much the answer. Now, remember, you have to go up here to the original equation and make sure you don't have a negative argument. So if you put 645 in for x, your argument is positive, so this answer does check, so you're good. Okay, on to the second problem. Now, this is the type of equation here in which we have logarithms on both sides, okay? And the steps for this type of equation went something like this. Step 1, simplify both sides all the way down to 1 logarithm. Well, that's already done for you. I've got 1 logarithm here, totally isolated. 1 logarithm here, totally isolated. Well, talk about an easy bonus point. I should have given you like 1/10 of a bonus point for this one. Step 2 says, after you've done step 1, step 2 says to cross off your logarithms and set the arguments equal. So 2x plus 7 equals x minus 4. Well, I'm going to bring this x over and make it a negative x. I'm going to bring this 7 over and make it a negative 7. So 2x minus x is x. Negative 4, negative 7 would give you a negative 11. And you know what? This is a pretty good problem. After all, I bet some of you forgot to check your answer. So if you got negative 11 for your answer, you're wrong. Come up here to your argument. Here's your argument. I'm going to underline it in red. Here's your argument right here. Okay? If you put a negative 11 in right here for x, Do this in your head. 2 times negative 11 is negative 22, plus 7 is negative 15. So your entire argument is a negative number when x is a negative 11. You can't have that. So the answer is no solution. So I guess it wasn't quite as easy as I thought. All right, there's your 2 review problems. Either you got no bonus points, a half a bonus point, or a half and a half is 1 whole bonus point. We're going to try to review a little bit every day. All right? Moving on. Let's grab your notes today and get started, please. Put the right button here. There we go. Okay, if you look at the top of your notes today, it says this: writing exponential functions. That's what we're going to do today. Contain your excitement. We're going to write exponential functions. The date today is the 24th, and the lesson number is 8.7. I'm just reading from the top of your handout, so just follow along as I read. Let me get a drink of water here. All right, here we go. If you'll look at the top of your handout, it says this: we have been graphing and solving exponential functions. Now we are going to learn how to write exponential functions, exclamation point. Now look at the next sentence. Do you remember the linear model y equals mx plus b? Well, here's the model we're going to use, and here it is. We're going to use this model right here, y equals a b to the x power. All right, that's the model we're going to use. Now, I'm going to read the steps. They sound complicated. Can I be honest with you? Today is much easier than Monday and Tuesday. So if you found Monday and Tuesday pretty easy, today's even easier. If you found Monday and Tuesday pretty hard, well, today's going to be easier. So even though the steps look really detailed, you're going to see it's really pretty simple to do. So here we go. Okay, let's look at these 5 steps. First of all, you substitute one ordered pair into your model and then solve the model for A. Secondly, you substitute the second ordered pair into your model. Then take your equation from step 1 and substitute this into your model. I will show you how to do all of this, rest assured. Then take your equation from step 2, solve it for B. And then take your B value and substitute it back into your model from step 1 and solve for A. And then do 6 cartwheels. I'm kidding. And then write the exponential function. Now, I know it sounds complicated, but it's really, really not. I'm going to give you 3 examples, and I'll probably be done teaching in about 15 minutes. So most of the time today is going to be working on your homework, okay? So be thankful for that. All right, let's go ahead and try the first problem in your notes. I want you to take these 2 ordered pairs, 1, 6 and 3, 24, and I want you to write an exponential model that would model these 2 ordered pairs. In other words, real quick here, if I had a point at 1, 6, which is about right here, then over 3, way up here at 24, didn't mean to do that. You don't have to write this down. This is all free of charge. And let's say you had an exponential graph that looked like this. Remember how we've graphed these curves, and they come down like this, and they have an asymptote and all of that? Well, if this graph right here passed through these 2 points right here, I want you to write the model for that graph, for that exponential function. And now I'm going to do it for you, so please follow along. Now don't get caught up in what, just read the steps and relax, okay? So step 1 says, substitute one ordered pair into your model and solve the model for A. So I'm going to go ahead and use this ordered pair because I feel like it. So this is my X and this is my Y. So here's my model right here. So y equals a b to the x power. Where the y is, I'm going to substitute 6. And where x is, I'm going to substitute 1. Everybody okay with that? Pretty simple. All right. Okay. So step 1 says substitute one ordered pair into your model and then solve for A. Now, if I want to solve for A, what are A and B doing together? They're multiplying, are they not? So if I want to solve this for A, I would simply divide by B. Those cancel and divide by B. So step 1 is done. Man, that is pretty simple. Step 1 is done. All right, that rhymes. So I took one ordered pair, X and Y, I substituted it into my model, and I solved for A. That's pretty basic math. Step 2, take your second ordered pair and substitute it into your model. So here we go. I'm going to take Y equals A, B to the X. And here's my second ordered pair. 3 is my X, Y is my 24. So where the Y is, I'm going to substitute 24. Where the x is, I'm going to substitute 3. Now let's read the rest of step 2. Take your equation from step 1 and also substitute it into your model. So just stop and relax and listen to me. Everybody understand step 1? Step 1, I took this ordered pair where the y is, I put a 6, where the x is, I put a 1. I then solve for a. Then step 2, you take your other ordered pair and you substitute it in. And then step 2 says take this down here from step 1 and substitute it in up here. We can do that. Look, guys, what does a equal? A equals 6 over b. 6 over b. Do you see that? A equals 6 over b. So where a is right here, I can put a parentheses and I can put 6 over b. And then bring down your b cubed. All right. Now, let's not get all caught up and let's just read the steps, okay? Step 2, I'm going to read it again. Substitute the second ordered pair into your model. Check, we did that. Then take your equation from step 1 and substitute this into your model. Check, we did that. All right, step 3. Now take your equation from step 1 or from step 2 and solve it for b. So let's solve this for b. In other words, let's get b all by itself. Well, first of all, you guys have always learned to simplify both sides whenever you can. So watch what I do. I can definitely put b over 1. Nobody would argue with me there, okay? And I can do some canceling. I'm multiplying these together. I've got 1b here and 3b's here, so I'm going to cross that b off and put a 1. Cross this off and put b squared. So I'm left with 6 times b squared is 6b squared, and 1 times 1 is 1, all over 1. I'm not going to put it over 1. That's a waste of space, but you hopefully see what I'm doing here. Let me go over this again one more time. If you're advanced, you might want to fast forward the video a little bit, but if you're struggling with this, please watch and I will help you, okay? All right. Now, we're going to solve for b. That's what step 3 says to do. Well, anytime you're solving an equation, you want to simplify each side as far as you can. We can't simplify 24, so we leave 24 alone. However, here, I can simplify this. It's 6 over b times b cubed. So put it over 1. And now you can do some canceling. You have 1b here. There's a little 1 exponent here, so we take 1b away, take 1b away from up here, and we're left with b squared. So 6 times b squared is 6b squared. 1 times 1 is 1. Now, we should know how to solve these. We've done tons of these. Excuse me. We divide both sides by 6. That would give me 4 equals b squared, right? And then we take the square root of both sides. Remember how to do that? So the square root of 4 is 2, and the square root of b squared is b. Mr. Erhart, you forgot to put plus minus. No, I did not. We learned back when we started this chapter on exponentials, we learned that your base can never be a negative number if you have an exponential function. So whenever you solve these types of problems, you don't want to put plus minus. You just want the positive answer. But you might not remember that, but I did teach you your base in an exponential function. That was back in lesson 8.1 at the start of the chapter, can never be negative. Okay? So we did step 3. Let's see what step 4 says to do. Take your b value and substitute it back into your model from step 1. Well, let's go all the way back to step 1. All the way over here. Here we go. Here's what we got out from step 1. Do you see that? Well, this step 4 says to take what you got for b and put it in for b and solve for a. So I'm going to circle this. We know what b equals, right? Sure. And now we're going to take this right here from step 1, 6 over b equals a. And where b is, step 4 says to take your b, which is 2, and substitute it back into that model. So 6 over 2 equals a. Look what a equals. A equals 3. You're done. You're ready to write your model now. Do you know what a is? Yes. Check. Do you know what b is? Yes. Check. So step 4 says write your model. So come up here. Here's your model. Now you know what a is. Now you know what b is. So your model is y equals 3. Then put a parenthesis for your b. 2 to the x power. You did it. That's all you got to do. So once you know what a is and once you know what b is, you substitute them in and you're good. Now it's a lot of work, but I don't find it hard like confusing or trying to solve it. I mean, you're just equations. You're just simply putting values in, getting values out, and going on from there. It's not that bad, all right? But what you do need is practice because we have a lot of steps. So here we go. Let's try the next one. Here's your model. Y equals a times b to the x power. And if you'll look in your notes, you'll see these two ordered pairs right here. 2, 18 and 3, 108. All right, here we go. Let's write the let's write the exponential function of the graph that would pass through these 2 points. So step 1 says, substitute one ordered pair in and solve for a. So I'm going to go ahead. I'm going to take my model right here, and this is my x, and this is my y. So where the y is, I substitute 18. And where the x is, I'm going to substitute 2. Now, step 1 says to solve for a. Well, a and b are multiplying, so I'm going to divide both sides by, I'm not sure why I put a b squared. I'm glad I caught that. Let's put an x right. No, that's right. It is supposed to be a square. Sorry about that. That is totally correct. Okay, so if we're going to solve for a, we divide this side by b squared, but we must also divide this side by b squared. So these cancel, and I have 18 over b squared equals a. Okay, we did it. That's step 1. We did it. Step 1 says, substitute one ordered pair in and solve for a. Check. All right, step 2 says, substitute the second ordered pair into your model. So I'm going to go ahead and do that. This is my x. This is my y. So where the y is, I put 108. And where the x is, in just a second, I'm going to substitute 3. Booyah. Good. Now, the rest of step 2 says, then take your equation from step 1 and substitute that into your model. So come down here. Here's your, I'm going to go ahead and label this from here on out. I'm going to call this the step 1 because we go back to that a lot. So, okay. So now we're going to take this and we're going to substitute it in. Well, a equals 18 over b squared. So where a is, I'm going to very simply substitute 18 over b squared. Is that okay with you guys? That's not too bad. And then here's your b cubed. All right? Now let's read the rest of step 2. Excuse me. Let's go on to step 3. Let's go back to step 2. We did step 2. We took this ordered pair and we substituted it in. Then we took this equation from step 1 and we substituted it in. We did step 2. Step 3. Solve your equation for b. Solve this equation for b. Well, anytime you solve an equation, you want to simplify both sides as far as you can. So we're going to go ahead and put, well, 108 cannot be simplified, but this side over here, look, put this over 1. These two fractions are multiplying. You've got 2 b's here and 3 b's here, so I can cross this off and put a 1. I take 2 b's away from this, and I'm left with b. So 18 times b is 18b, and 1 times 1 is 1, so 18b. Now we're going to divide both sides by 18. So we're going to take 108, and we're going to divide it by 18, and you get out 6. So 6 equals b. Not bad. So we solved it for b. Cool. Let's go on to step 4. Take your b value, which is 6, and substitute it back into your model from step 1. So here's that step 1 model way over here. 18 over b squared equals a. And step 4 says to take your b value, which is 6, and substitute it in. So 18 over 6 for b, and then squared equals a. Well, use your calculator on this. You'll see you're going to get out 1/2. You'll get out 1/2, which is fine, no big deal. 6 times 6 is 36. 18 over 36 reduces to 1/2, or 0.5 if you want a decimal. That's not a big deal to me. So now you know what a is. Now you know what b is. So step 5 says write your model. So here's your model. Y equals, where the a is, I'm going to put 1/2. And then parentheses for b, I put a 6, and then to the x power. There you go. You found an exponential model, contain your excitement, that is a representation of a exponential graph going through these 2 points right here. All right, pretty cool stuff. All right, let's try one more example, then you're on your own for homework. Let me give a little plug for homework. You are to do the homework. There has to be give and take through this course that we do. Sooner or later, you men have to learn responsibility to do what you're supposed to do, not just because someone's standing over you watching you, okay? So you are to do the homework. Now you might want to watch the video and do your homework that way, which is not cheating. That's totally fine. Or you might want to do the homework first and go back and grade it and just watch the video and check it, whatever. But you are to do the homework. Okay, I'm not going to collect it. I'm not going to grade it, but you are to do the homework. Okay, let's go ahead and do the last prob, and we're finally done. We're going to throw some decimals at you, which is okay, not a big deal. 3, 13.5. We have calculators, so I think that'll make it a little easier. 5, 30.375. Now, what we're going to do is we're going to write a linear model that models the exponential graph going through these two ordered pairs. Step 1 says take an ordered pair and substitute it in and solve for a. So here's my ordered pair. Where the y is, I simply put 13.5 equals, and then where the x is, I'm going to put a 3. Now we're going to solve for a. Well, if I'm going to solve this for a, which is what step 1 says to do, I'm going to divide both sides by b cubed. b cubed. These cancel, leaving me with just a, and over here I'm left with 13.5 over b cubed. Now, that's what a equals. I'm going to circle it. I'm going to call that step 1. We're going to go back to that a couple times later. All right, step 1 is done. We substituted one ordered pair in, and we solved it for a. Get a drink of water here. Okay, now step 2 says substitute the second ordered pair into your equation. So this is my x, this is my y. Where the y is, I substitute 30.375. And then I come over, and where the x is, I'm going to substitute a 5. Good. And then it says to take your equation from step 1 and also substitute that into your model. So here's the equation from step 1. What does a equal? A equals 13.5 over b cubed. So where a is, and I know that's kind of weird and a little annoying to have decimals, but it's not going to kill you. It's totally fine. Where the a is, I'm going to substitute 13.5 over b cubed. And then, of course, I have b to the 5th right here. Now, we're going to solve this. If you'll look at step 3 says solve your equation from step 2 for b. We're going to solve this for b. Well, anytime you solve an equation, you want to simplify each side as far as you can. Now, I cannot simplify 30.375, but I can simplify this side over here. These two fractions are multiplying. Put this over 1. I have 3 b's here, so take 3 b's away. Take 3 b's away, I'm left with b squared. So 13.5 times b squared would be 13.5b squared. And then we're going to divide both sides by 13.5, which I have not done yet, so give me a second to do that. 30.375 divided by 13.5, and you will get 2.25. So 2.25 equals b squared. And now you should know what to do next, men. You take the square root of both sides. And so if you take the square root of 2.25, you do get out an exact number. You get out 1.5. And of course, the square root of b squared is just b. So there we found b. We're halfway done. Once you find a and b, you can write your model. So we're halfway done. Okay, step 4. Take your b value, right here, 1.5. Take your b value and substitute it back into your model from step 1. So here's your model way over here from step 1. So I'm going to write it right here. I guess I should color code these. It might help a little bit. Anyways, 13.5 over b cubed equals a. And where the b is, I'm going to substitute 1.5. So now I have 13.5 over 1.5, and notice it's b cubed, so when I put b in, I have to cube it, equals a. So now it's just a calculator problem. I'm simply going to type into my calculator this expression, if you give me a second to do that, and you get out 4, so it actually works out to a whole number, so 4 equals a. So you did step 4. Step 4 said take your b value, substitute it into the equation from step 1, and solve for a. Now you know what a is. Now you know what b is. So write your answer. Y equals a. So I'm going to put a 4, and then b, put parentheses, 1.5 0.5, all of that to the x power. You did it. Not a long video, okay? So there we go. And now I'm going to give you 352 homework problems just to make men out of you. So here we go. Now, how you do your homework is totally up to you, okay? You're welcome to watch the video if you don't have a lot of confidence. You're still getting practice the right way. Remember, practice does not make perfect. As a former coach, I said all the time that perfect practice makes perfect. And that is so true. To practice something incorrectly is not going to help you. To practice something the right way will develop good habits, okay? So you're welcome to watch the video for this homework from here on out, or you can stop the video now, work on your homework, check them in the back of the book, and then watch the video for the ones that you missed, okay? But there's your homework. I'm being a little sarcastic with you, a whopping 5 problems. So I think that's more than reasonable. And go ahead and get started now, whether you're going to watch the video or whether you're going to do it on your own and then go back later. Okay, let's go ahead and start off with number 17. Number 17 right here. All right. Step 1 says to take one of your ordered pairs, and let me draw a line right here across so we can divide that. Here's your ordered pairs for this problem, 1, 4, and your other ordered pair is 2, 12. Now, this is an x, this is a y, this is an x, this is a y. Step 1 says take one of your ordered pairs and substitute it into your equation and solve for a. So here we go. Your model is y equals ab to the x power, so 4 goes in for y and 1 goes in for x. Now we're going to solve for a, so we divide both sides by b. These cancel out, and step 1 is completed. 4 over b equals a. Okay, step 2 says take your other ordered pair and substitute that into your model. So where y is, I substitute 12. Where x is, I substitute 2. Then step 2 says to take this equation right down here and substitute that in for a. So here we go. 12 equals, where a is, I'm going to put 4 over b and then bring down my b squared. All right, and then step 3 says to solve this for b. Solve this for b. Well, I can't simplify 12, but I can simplify this side over here. These two fractions are multiplying, so take a b away from here, take a b away from here. And 4 times b is 4b, 1 times 1 is 1, so we have 4b. Now divide both sides by 4, and 3 equals b. So we're halfway done, we found b, just like that. Now step 4 says take your b value, which is 3, and substitute it in for b right there. So we're going to do that over yonder, over here. So 4 over b equals a. So 4 over 3 equals a. So now you know what a equals. Pretty simple, 4/3. So your answer is y equals, where a is, we put 4/3. Then parentheses, where b is, we put a 3. And then our x. So there's number 17. Now I always pause and check these in the back of the book to make sure I'm not making a mistake somewhere. Let me check that quickly, and yes, we are totally good. I think in the back of the book, they put their parentheses here, like this, and the 3 here. That's pretty unorthodox. That's not normal, and either one is fine. It really doesn't matter, but usually this is how you'll see it written, like this. So, all right, moving on to number 19. Number 19. Your 2 ordered pairs for number 19 are 6, 8. That's your x, that's your y, and 7, 32. This is your x and this is your y. Okay, using our model, y equals ab to the x power. Step 1 says substitute one ordered pair in and solve for a. So 8 equals ab to the 6th power. Now let's divide both sides by b to the 6th power to get a by itself. These cancel. And so we have done step 1. 8 over b to the 6th power equals a. Now let's go on to step 2. Step 2 says to substitute your other ordered pair into the equation. So 32 equals a b to the 7th power. And then step 2 also says to take this equation right here and substitute this part here for a. Substitute that in for a, because a equals 8 over b to the 6th. So where a is, I'm now going to very simply substitute 8 over b to the 6th, and then bring down my b to the 7th. Well, we cannot simplify 32, but we can simplify this side over here. They're multiplying. We have 6 b's here. Take those away. Take 6 b's away from up here. We're left with b. 8 times b is 8b over 1, because 1 times 1 is 1. Divide both sides by 8, and 4 equals b. So we're cruising along. We did step 2 and we did step 3. Step 3 says solve for b. And now we're moving on to step 4. Step 4 says to take this b value and substitute it in for b right here, and then you'll know what a is. So we're going to take this expression right here, 8 over b to the 6th equals a. And where b is, we're going to substitute 4. So it's b to the 6th. So I'm going to put 4 to the 6th power. And then, of course, using your calculator, you should get a fraction. Let's see what 4 to the 6th power is. It would be 4,096. So you end up with 8 over 4,096. I suppose I would allow a decimal here. I'm not a huge fan of decimals. I would prefer the fraction, which is, if you reduce that, you get 1 over 512. But if you want to use a decimal for a, that's fine. The decimal would be 0.001953, so you could round that wherever you wanted to. Anyways, there's our b, here's our a. You're ready to write the equation. So the equation is y equals 1 over 512, parentheses, then put your b in, which is 4 to the x power. Let me check that in the back of the book real quick, and we're going to go ahead and move on. It's number 19. And we actually got 2 right, so miracles still happen. All right, let's take a look at number 20. Number 21, excuse me. Hopefully you're doing the odds, not the evens. When I gave you this assignment, did I say the odds? I hope I did. I did. Okay, good. All right, number 21. Number 21. Your ordered pairs are 3, 8. I'm going to go a lot faster now, guys. I've pretty much held your hand through most of this, so we're flying now, okay? I'm going to quit putting x and y and all of that. You know which one's x, you know which one's y. Okay, step 1 says substitute one ordered pair in, and then solve for a. If I solve for a, I'm going to divide both sides by b cubed. Divide both sides by b cubed. Those cancel. 8 over b cubed equals a. All right. Now, step 2 then says to take your other ordered pair and substitute that in. So 64 equals a b to the 6th power. And then step 2 also says to take this right here and put that in for a right there. So 64 equals, then for a, I'm going to put 8 over b to the 3rd power times b to the 6th. That is a b right there, b to the 6th. All right, so I can simplify the right side. I'll do that very quickly. Put this over 1. They're multiplying. Take away 3 b's. Take away 3 b's, so I'm left with b to the 3rd. 8 times b cubed is 8b cubed. Divide both sides by 8. You will get 8 equals b cubed. And men, you should know what to do. You have a 3 right here, and you don't want that 3, so you must take the cubed root. The cubed root of both sides. Cubed root looks like this. So you're going to take the cubed root of both sides. The cubed root of 8 is 2, and the cubed root of b cubed is b. All right, there we found b. Then your steps say to take this right here and substitute that in for b, and you'll know what a is. So we're going to do that right over yonder again. So 8 over b cubed equals a. 8 over 2 to the 3rd power equals a. And that would be 8 over 8, because 2 times 2 times 2 is 8. 8 over 8 is 1, so a equals 1. So now that you know what a and b are, write your final answer right here. Y equals 1 parentheses 2 to the x. Now I know you guys, you're saying, Mr. Erhart, do we need that 1 right here out front? No, you don't. You could just put y equals 2 to the x. Either way is acceptable. It's not a big deal. Let me check the back of the book. We do have it right, so we're 3 for 3. Not bad today. All right, let's take a look at number 23. It's our next to last problem, and then one more, and we're finished. So here we go. All right, number 12. Wow, man. Fractions, what are they doing to us? All right, here we go. 4 comma 112 over 81. Man, these authors had too much free time on their hand. And then the other ordered pair is negative 1 comma 21 over 2. All right, here we go. Step 1 says substitute an ordered pair in and solve for a. So 112 over 81 equals a b to the fourth power. Well, divide both sides by b to the fourth power, and you would have 112 over 81. All of that is over b to the fourth power, and that equals a. So I divided both sides by b to the fourth. Now, step 2 says to take your other ordered pair and substitute that in. So we have 21 over 2 equals a b to the negative 1. Oh, that'll be interesting. Negative 1. That'll be a lot of fun. All right, and then also we're told in step 2 to take this expression right here and substitute that in for a. So now I have 21 over 2 equals parentheses. Wow. You know what we better do? We had better simplify this over here. Okay? So let's pause and let's simplify this. Let's simplify this whole mess right here. You know what this really is? It's 112 over 81, right? Do you see that? Divided by, that's what that bar means. It means divide. Divided by, what? B to the fourth? We'll put that over 1. So, 112 over 81 divided by b to the fourth. Well, whenever you're dividing two fractions, don't you multiply? Don't you flip this fraction right here? I think we flip it, do we not? So it's 1 over b to the fourth, and then we multiply. So 112 times 1 is 112, and 81 times b to the fourth is 81b to the fourth. There, that's a lot more acceptable than this big mess right here, okay? So we took this whole complex fraction, that's a fraction within a fraction, and we simplified it down to this right here, okay? All right, let's continue on. So where a is, I'm going to substitute 112 over 81b to the fourth. And I'm going to multiply that times, oh, be careful, students. Let's really be careful here, okay? We have, this will be a tough problem, we have b to the negative 1 times b to the negative 1. Do you see that? And that's going to be interesting. I think I'm going to, this is a tough problem, but it's homework and it's so good for you. That's what we try to do, is challenge you guys. B to the negative 1, let me write that again. B to the negative 1. Let's do a side note down here. Isn't b to the negative 1 the exact same thing as 1 over b? Haven't I taught you guys you can move, if you have a negative exponent, you can move it to the top or the bottom and it gets rid of the negative exponent? Sure, I have. So really, instead of putting b to the negative 1, if it's okay with you guys, I'm just going to go ahead and put 1 over b. That'll make it a lot easier. All right, now let's go ahead and simplify this right side. So I have 21 over 2 equals, okay, 112 times 1 is 112. And then 81b to the fourth times b to the 1 would be 81b to the fifth. Remember, b to the fourth times b to the 1, you add your exponents. Now, students, this is definitely a difficult problem, but don't lose sight of the trees for the forest. Step 1, substitute your ordered pair in, solve for a. Step 2, substitute your other ordered pair in and your a in and solve for b. So we're solving for b. So please don't lose sight of that, okay? Now, there's a couple ways to do this. I've told you guys before, let's do a side note up here. Remember, when you have a fraction equals a fraction, you can cross multiply. Whenever two fractions are equal, you can cross multiply. 5 times 7 is 35, and 9 times x would be 9x. And then after you cross multiply, you set them equal and you solve. That's an old, pretty much Algebra 1 procedure. So we have two fractions. Here's a fraction, here's a fraction. They're equal. We can cross multiply. So if I take 2 times 112, that's going to give me 224. And if I take 21 times 81b to the fifth, I'm going to get 1,701 b to the 5th. And that's okay, no big deal. And now, actually, I really don't want that circle there, so I'm going to get rid of that circle. So we cross multiplied, and when we cross multiplied, we got 1,701 b to the 5th, okay? Now, next, we would divide both sides by 1,701. And you should get this right here. I'm going to go ahead and make it a decimal. You should get 0.1317 equals b to the 5th, okay? And now, Mr. Erhart, what do? Well, you got to take the 5th root of this number. You got to take the 5th root of this number. Do you remember how to do that, students? If you're listening carefully, I'll remind you how to do it. You go to your math, look at the left side of your calculator, third button from the top, it says math. Hold it, don't push that button. So go ahead and forget that I said to do that, just stop, okay? First of all, you're doing the 5th root, okay? You're taking the 5th root of one side, it'll look like this. If you look at the screen here, you get a connection here. Here we go. What you're going to do is you're going to take the 5th root, like this, of both sides. So, first of all, you need to type a 5 in for the 5th root. So go ahead and hit 5 on your screen. Then hit your math button. And then look at option number 5. Scroll down to option number 5 and hit enter. And then you should be able to go ahead and type in that decimal. And you should get out 0.66666 repeating. So you're welcome to use 0.7 equals b. I don't know why I put a repeating symbol. 0.7 equals b. Or to be honest with you, students, if you want it in fraction form, you get out 2/3. Either way is fine. I think the back of the book has 2/3. I really don't care. Either way, you can call this b, or you can call this b. Either way is fine. Wow, that was a killer. This is good though, guys. I mean, hey, at least we're challenging you. There's only one more left. So, and then we're done with our homework. So the last, one more problem after this. So the last step now is we know what b is. So we go over here and we substitute b in. That's not too bad. I'm going to go ahead and use the fraction 112, 81, 112, 81 b to the 4th. So where the b is, I'm going to substitute 2/3 to the 4th power. And now let's see what happens. This will be interesting. So here we go. First of all, I would have 112 over 81 times 16 over 81. Your calculator will do that for you guys. 2/3 in parentheses to the 4th power. And now take 81 times 16 over 81. Your calculator will do that for you. You will get 16. And then 112 divided by 16 will give you 7. There we go. So all of this, of course, I should have put all of that equals A. All of this equals A. That equals A. So 7 equals A. And how do I know this equals A? Right over here, remember? Right here. There we go. This was a good one. Wow. So, man, where do we write our answer? I have no earthly idea. I guess we'll squeeze it up here. So y equals A is 7, and then B would be 2/3, all of that to the x power. There we go. Well, let's check the back of the book. Watch us be totally wrong. We'll have to redo this whole problem. Wouldn't that be wonderful? Number 23. Wow, we're still batting 1,000. We got it right. So good. Okay, moving on to the very last problem finally. And if you've watched all of these, I feel sorry for you. Hopefully you'll be able to work ahead on your own. Boy, they love fractions, don't they? Okay, 2 comma 25 over 4. And then 4 comma 625 over 4. Okay, let's write the exponential function for these two ordered pairs. Step 1, of course, would be to take one of your ordered pairs and substitute it into your model. So 25 over 4 equals a b to the 2nd power. And then step 1 says solve for a. So we're going to divide both sides by b squared. So 25 over 4 all over b squared equals a. Now we're not going to make the same mistake we made on the last problem. We're going to simplify this real quick. So remember, let's do a side note over here. 25 over 4 over b squared. That means divided by b squared over 1. Okay, so 25 over 4, this big line means divided by b squared. So what I can do is I can flip this fraction and I can multiply. So really I have 25 over 4 times 1 over b squared. And so what you end up with, 25 times 1, of course, is 25, and 4 times b squared is 4b squared. And all of that equals a. Okay? All right, moving on to step 2. Step 2 says to substitute your other ordered pair in, so 625 over 4 equals a b to the 4th power. And then step 2 also says to substitute this expression in for a. So a equals 25 over 4b squared. We're going to put that in for a right there. All right, let's switch colors so it's not so difficult to see where we're at. So 625 over 4 equals, and then for a I'm going to put 25 over 4b squared times, and of course it's b to the 4th power. I can in a second do some simplifying. Now I can't simplify the left side. I'm going to solve for b now. I want to solve for b, and I cannot simplify the left side. 625 over 4 stays 625 over 4. My voice is really getting rough. Let me get a drink of water here. Okay, so 625 over 4, and then we can simplify this side over here. Put this over 1. They're multiplying. You have 2 b's here. Take away 2 b's up here. And 25 times b squared would be 25b squared. And 4 times 1 is 4. Look at that. Not too bad, huh? And now we should know what to do. Remember, when two fractions are equal, we can real quick cross multiply. So I can take 4 times 25 over b squared, and I would get 100 b squared. Then I can take 625 times 4, 625 times 4, and I would get, let's see, I'm doing it in my head, 20, 0, I think 2500. Better check that real quick. Yep, 2500. So cross, whenever you have two fractions that are equal, you can cross multiply and set them equal. So I've done that. Now divide both sides by 100, and you will get b squared equals 25. And now you don't want that 2 there. You don't want b squared. So we're going to take the square root of both sides, the square root of both sides. And if you do that correctly, you will get b equals 5. There we go. So now we know what b equals. Don't worry about the plus minus in these problems like I told you earlier. Now, the next step says to take your b, which is 5, and substitute it in over here and get out your a. So I have 25 right here, 25 over 4b squared. So I'm going to put 4, then parentheses, then 5, then squared. Now, you should know, students, by now, this is Algebra 2, you should know this actually in middle school. In the bottom of your fraction here, you do not multiply 4 times 5 first, you do your powers first. So in the bottom here, you really have 4 times 25, because 5 squared, 5 times 5 is 25. And then we would have 25 over 100, because 4 times 25 is 100, and now if you reduce that fraction, you get 1/4 equals a. Okay, so now we know what a is, now we know what b is, so we can write our final model to look like this. Y equals a is 1/4, b is 5, and then my little x up here for an exponent, and we are finished. All right, so hopefully this was a help to you. Hopefully you're getting your homework done. 2 days left, guys, Thursday and Friday, so hang in there.